Hello students, in the previous lecture we discussed about the application of Ampere circuit law, that is coaxial transmission line. Now let us consider one more example, that is how magnetic field arising from the current sheet. So let us consider a sheet of a current flowing in a positive y direction and located in a z is equal to 0 plane. So as you can see in the figure, you can consider a uniform plane current sheet which is in the y direction and which is having a z is equal to 0 plane. So for uniform plane current in y direction, we expect an x directed H field from symmetry, right? So we may think of a return current as equally divided between two distant sheets on the either side of sheet, as we are considering a sheet of uniform surface current density, that is K is equal to Ky Ay as shown in the figure. So H cannot vary with X or Y if the sheet is subdivided into number of filaments. So it is evident that no filament can produce a HY component. Moreover, the Biot-Savart's law shows that contribution of Hz produced by symmetrical located pair of filament cancel. So thus Hz is also 0. Only Hx component is present. So therefore we need to choose the path for applying the Ampere circuit law to the current sheet. That is, you can see in the figure 1 1 dash, 2 2 dash, 3 3 dash. So here, after applying the Ampere circuit law to the path, we find the two figures are there. You can observe here Hx1L, which is nothing but along the positive z, that is z is more greater than 0, plus Hx2 minus L is along the negative z direction, so which is 2 2 dash. Now Hx1 is along 1 1 dash, Hx2 is along 2 2 dash. So we need to find out the magnetic field intensity. So therefore that is nothing but equal to Ky into L. So or you can write it as Hx1 minus Hx2 is equal to Ky. So in other words, the magnetic field is discontinuous across the current sheet by the magnitude of surface current density. So this is what a magnetic field intensity along the current sheet, that is Hx1 minus Hx2 is equal to Ky in this slide, right? Next, in the next slide, if instead the upper path is elevated to the line between 3 and 3 dash, the same current is enclosed and we would have Hx3 minus Hx2 is equal to Ky. So here what happens is, so same figure is there, but here the path is elevated. So that is what, instead of from 1 1 dash, it is elevated to 3 3 dash, and the magnetic field intensity will be Hx3, right? So therefore from this we conclude that Hx3 is nothing but equal to Hx1. So the field is constant, so you can tell that the field is constant in each region, that is above and below the current plane, right? So you can observe in the figure here, so there is Hx3 is available, that is over 3 3 dash. Now by the symmetry, the field above the sheet must be same in magnitude as the field below the sheet. So therefore we may state that Hx is equal to half of Ky. So that is, if it is a greater than 0, more, that is what z might be greater than 0. If z is greater than 0, Hx is equal to half of Ky, and Hx is equal to minus half of Ky if z is less than 0. So that is what you can have Hx, the magnetic field along the x direction, right? So next, the actual configuration is shown below, in which magnetic field above the current sheet is equal in magnitude but the direction opposite to the field below the sheet, right? So whatever in the previous thing, that is the same, it is shown here, but here what is happening is in the figure you can see hx is equal to half of ky when z is greater than 0, and hx is equal to minus half of ky when z is less than 0. So we can show here uh, a unit vector to represent the magnetic field. So the field in the either region is found by the cross product, that is what h is equal to half of k cross an, that is cross product of k and an. So where an is nothing but unit vector what that is normal to the current sheet, and that points into the region in which magnetic field is evaluated, right? So that is what you can represent in this slide. You can show that. You can also show the unit vector direction for the both positive z is equal to 0 and negative z, where magnetic field intensity will have certain value in the both the cases.